This evening I just wanted to make a few remarks really about the climate change issue. We're 1 week now before what many people are billing as the most important international meeting in the history of humankind, and really just to pass a few reflections across about what this means in a wider sense, because many of us see this quite correctly as an environmental challenge about melting ice caps and disappearing species, but of course this is a much deeper challenge for humankind, I would argue, and I'd just like to explore some of the reasons for that this evening, and then perhaps we can engage in a discussion afterwards. So, the climate change issue has been on the international agenda now for very many years, and I was lucky enough in my early days at Friends of the Earth to be involved in the campaign leading to the Earth Summit in 1992 in Rio de Janeiro, where the international treaties on biodiversity and climate change were first put in place by the world's governments. The Climate Change Treaty, as many of you will know, had as its central objective the aim of avoiding dangerous climate change, so that food systems and ecosystems could adapt at a pace that wouldn't be exceeded by the level of warming. Now, in those days, 17 years ago, the climate science was, compared with now, relatively uncertain in terms of the sensitivity of the atmosphere to different levels of pollution, and also in terms of the speed with which changes might take place as a result of human activities, including obviously the combustion of fossil fuels and the clearance of rainforests. Our knowledge has gone very far, very fast in the intervening 17 years, and we now know much more about what dangerous climate change is likely to entail. And if you speak to many people around the world, they would say it's already happening. If you speak to some of the farmers in East Africa, for example, or some of the indigenous people living in the Arctic region, they would tell you that changes are already taking place which are exceeding their ability to cope in terms of the lifestyles and kinds of economies that they've evolved over literally thousands of years in some cases. But notwithstanding the changes that are already going on as a result of an average global temperature increase of 0.8 degrees compared to pre-industrial times, the projections in the scientific models are now enabling us to make some judgments about what might be a global level of warming which might overwhelm our ability to cope, or certainly cause us serious difficulties in maintaining economic and social well-being going forward into the 21st century. To cut a long story short, I'm sure many of you have seen some of this number crunching. In order to maintain a moderate level of risk in terms of food security, ecosystem change, rising sea level, damage to infrastructure, and all of these trends that follow the warming that's already underway, we probably need to stabilise the temperature increase below 2 degrees compared to the pre-industrial average. Now, that's a global average, and in the Arctic that may lead to 8 degrees of warming. In other parts it may lead to temperatures being pretty similar to how they are now. But it's a dramatic change if one looks back over the recent history of the Earth in terms of that level of warming occurring over what could be as little as 70 years from now. And in order to avoid going above that 2 degree average global temperature increase, the scientists are telling us that to have a reasonable chance of this, a 50-50 chance, we need to stabilise concentrations of greenhouse gases at the equivalent of 450 parts per million of carbon dioxide. And the equivalent number is quite important because that accounts for the warming effect of methane, nitrous oxide, and the so-called industrial gases, CFCs, which depleted the ozone layer, HFCs, sulfur hexafluoride, and some others. These gases are adding to the carbon warming, and we need to take a view of the whole lot. Now, if you look at the 450 parts per million stabilisation goal, you realise that we're already pretty close to this. We're at about 437 parts per million. Some of these estimates vary in terms of the warming potential of some of the industrial gases, but that's a figure that's widely cited. And if you then remember that we're going up at 2 to 3 parts per million per year in terms of the additional release of greenhouse gases, you don't need to be a mathematical genius to work out that the distance between where we are now and where we need to stabilise is less than a decade. And if one then looks at the momentum in terms of the global economy and the fact that China is still building a couple of 500 megawatt coal-fired power stations per week and adding to its energy generating capacity the equivalent of the entire UK energy base every year, you realise that we have something of a problem. So certainly we have to talk about targets and timetables. We have to have a clear view of what we need to cut by over what timetable, and the political job in Copenhagen is going to be very much about dividing up that cake in terms of who's got the right to use up the remaining carbon budget and who's going to cut very quickly. And actually some of those figures I've just told you, a lot of people disagree with them. They think we should be stabilising at below 400 parts per million. And you may have come across a campaign called 350.org, which is campaigning for a stabilisation goal of 350, which means we not only have to cut to zero, but go below zero, i.e. remove carbon dioxide from the atmosphere in order to stabilise near there. And there are some very heavy-duty scientists who are backing that campaign, including Jim Hansen, who was one of the first people to be raising the alarm about this subject in the United States way back in the 1980s. Now this presents something of a problem because our historic approach to solving environmental challenges doesn't really fit with this particular challenge. And many years ago when I was involved in the early days of Friends of the Earth and right through the 1990s up until quite recently, there was a fairly traditional way of approaching environmental problems. You could call it really the kind of traditional environmental protection agenda. So an issue would be raised up, the toxic effects of pesticides or the impact of acid rain emissions on habitats, or for example the impact of ozone depleting substances on the atmosphere and the threat posed thereby. And there would be an argument in public. Most traditionally it would be between the environmental groups and some industrial sector. There would be a scientific debate played out in the media. There would be political lobbying, and then in the end the government would come forward with some timetables and some targets, and there would be some regulation, and the problem would be phased out. And if you look back at what we've done in this part of the world, in the European region, over the last 20 years, let's say, it's been really successful. We've managed to pretty much phase out ozone depleting substances. We've managed to regulate the coal sector, in particular, to reduce emissions causing acid rain by 80%. We've phased out the worst pesticides, and we've regulated whole areas of the European continent to be primarily for the protection of biodiversity, habitats directives, national park programs, sites of special scientific interest in this country. All of these things have happened on what you might regard as a relatively narrow environmental protection agenda, where you regulate a particular sector or a particular activity and it's phased out, and the rest of society doesn't really need to worry too much about the implications of this, because the lights still come on, we still have economic growth, and we still consume at a high level, and we still have a society that was familiar in terms of what we were living like before the environmental problem was solved. In the case of the climate change challenge, however, things are very different indeed, because there isn't one single sector we can regulate to phase out the pollution. Unfortunately, this goes right across the piece. So pretty much all of our energy supply has some impact on the atmosphere in terms of climate change, even the manufacturing of wind turbines. We have a major issue in terms of our transport system, which is pretty much entirely fueled by mineral oil. Some of it's coming from nuclear power in terms of trains, and we have a few bicycles, but 90% of our transport is fueled by energy coming from fossil energy. Our housing uses up vast amounts of electricity and gas, and of course we have major challenges in terms of land use. Not only do we have an agricultural system which in this part of the world requires something like 10 calories of fossil fuel to produce each calorie of food that we eat, but also we're continuing to clear land on a grand scale at the global level, something like 6 million hectares of tropical rainforest disappearing every year, accounting for about 50 emissions going into the atmosphere. The way we consume, the way we waste, the way we use natural resources, all of these things are embedded in the climate change challenge. And then when you juxtapose that to the inevitable program of adaptation that now has to take place in terms of countries having to adapt to the effects that inevitably will come through, even at the level of warming we've got now, and then look at the inequalities in the world in terms of rich countries and poor countries, you see that you can't ban one particular activity or regulate one sector in order to solve this. It goes far, far deeper.